Hi guys, welcome back to Learn with W3 Schools, and we are using W3 Schools website to learn R programming language. My name is Dr. Zishan and I have been talking about R in my previous sessions. This is I think the fourth one, and this way we're going to talk more about while loop. If you're here for the first time and still haven't subscribed the channel and interested in learning programming language with me using W3 Schools as a reference website, well, please do subscribe. Leave your comment below what you are learning, what you want to learn next. Helps us a lot. Okay, so without further ado, let's begin. Now, let's talk more about our while loops. Loops can execute a block of code as long as a specified condition is reached. The way the loops work is that they repetitively cycle through your code, the same block of code again and again until a condition is satisfied and becomes true. As soon as the condition becomes false, the loop breaks and stops the execution. It is different from if else because if else again also checks the condition, but if condition is true, if else only execute once. The way the loops work is if the condition is true, they execute the block and the code is again repeated. Check the condition again execute the block. So it's a cyclic motion. It keeps on repeating itself. That's what basically loops does. In our programming, conventionally, we have two types of loops. We have a while loop and we have a for loop. Let's go more into while loop and then we'll talk for loop later on. So these two loops are primarily used in our programming language. How the while loop works? Well, in order to use the while loop, what we need to do is we use a keyword called while, bracket start, bracket close, and then we specify a condition, again using the same relational operators that we have talked about in previous sessions. Okay, so we use I is less than 6, means we check a condition, then block of code starts. Again, similar to if else, while loop also has a block of code. Anything you write inside this block will be considered as a body of while and will repeat itself until this condition becomes false. Okay, so then it prints the value of I. Then here's the key step: we increment the variable. Now this loop has three major parts that needs to be understood for the loop to work properly. Every loop, either while loop, for loop, same goes for every other programming language as well. Every loop needs to have a variable. Okay, we initialize a variable, then this variable is used as a conditional evaluating parameter. In this case, I is being used as the key parameter that is being evaluated here. Then third part is the increment of that variable, so that at a given point this condition becomes false. If we don't do that, the condition will remain true forever and the loop will keep on repeating forever and it will become an infinite loop. That's the pitfall of using loops. So we have to be very careful about that. Again, every time you use a loop, just have these three benchmarks. Initialize a variable, use it inside a conditional operator, and then use it to increment the variable value as well. So we increment it, then we check the condition, print the statement, we increment it, check the condition, print the statement. That's how the loop works. So here I belongs to I plus 1. So what we're doing is we're taking the current value of I, add 1 to it, and then assign it back to the value of I. In other programming languages, you can use x plus plus, the simple increment operator, decrement operator. Again, the same thing. In our programming, we've talked that we use this arrow function less than minus sign as an assignment operator. So here we are assigning the current value of I, add it with 1, so plus 1, and then assign it back to the I variable. Make sense? So this is how the loop works. So if you execute the code, see, we get multiple lines of statements being printed. That's one of the primary outcomes of a loop. What it does is it allows us to print multiple statements using the minimum code. Okay, so here we are printing up till 5 using these 5 lines. So if we change this to, for example, 1000, now the same code will actually repeat itself 1000 times until the value of I becomes, sorry, not 100, 1000, until the value of I becomes equal to it and the condition stops. So this is what the loops do. It allows us to repeat certain piece of code multiple number of times in the minimum written form. Make sense? Perfect. So now again what's happening here is the first thing we do is we initialize a variable. So I is being initialized with 1. Then we use the value of I and we evaluate a condition here. So in this case, if I go back to my original value 6, wow, now what we're doing is we're taking the value of I is less than 6. So we're checking a condition. Is the value of I less than 6? The condition becomes true. The block executes. Within the block, we print the value of I, which initially is 1, okay, because we have initialized it 1. Then we increment the value of I. So I plus 1 becomes 2, assign it back to the value of I, and then because this is a loop, the body will automatically re-execute. Again, check the condition. Now I becomes 2 because we just did the increment inside the block. 2 is less than 6, condition becomes again true, print the value of I, do the increment, now becomes 3, 3 less than 6, condition becomes true. Print the statement, do the increment 4, then again 4 less than 6, true. Again print the statement 4, then go back here, do the increment, value becomes 5. Then again I is less than 5, condition becomes true. Print the value of 5 from here, do the increment. Now it becomes 6. Because now it becomes 6, this condition becomes false. I is 6, less than 6, condition is false, the loop breaks, no more execution code. That's how the loop works. Okay, so remember to increment I or else the loop will continue forever. So this increment statement is quite important. If this doesn't change the value of I, the value of I will actually remain same forever. And then that will mean the loop will run forever. Then within the loops, we use something called a break statement. Now, break statement, we can stop the loop even if the while condition is true. It is used in a certain condition to abruptly stop the flow of a loop. So for example, if you're searching, as soon as the word is found, no longer need to search the remaining content, just break the loop. Makes sense, right? So this is what we're trying to do. So if I have I is 1, I is less than 6, print the value of I, do the increment. Now check if the I is 4, break. So if the condition is satisfied, just do the break. What break will do, it will stop the execution flow. So if you execute the code, you would see that the value only prints up till 1, 2, 3. As soon as the value reaches to 4, it breaks and the execution stops. Even though the condition is 4 less than 6, this is true, but because we have used the break statement, the statement breaks here. This is quite feasibly and quite popularly used, especially when we're doing searching or trying to find something from a fair files or data, or whether a certain benchmark has already been reached. So while allows us to cycle through a bunch of data, but if we found a data or we have a certain benchmark, just stop it there. To do that, again, we use a break statement to break the execution flow. Okay. Similarly, we have a next. Next statement, we can skip an iteration without terminating the loop. So for example, if we want to skip certain outputs from the code, again, if there's a character that we want to say, hey, if you find this character, just skip it. If you find this variable name, just skip it. If you're doing some searching, if you find this character, just skip it. In that case, we use the next statement. This is equivalent to continue in other programming languages. So if you are familiar with Java or C# or Python for that matter, they all have a statement called continue. In our programming language, we use something called next. So the way it works is, again, we have to use it with the if block, same as the break statement. They also need to be in if, so that when a condition is met, it breaks it based on the condition. Same goes with the next as well. But what it does is that when it prints it, it will start from the value 0, prints the value 0, then prints 1, then prints 2. As soon as it reaches 3, it just skips the 3. So if you execute the code, you will notice we have 1, 2, and 3 is missing. 3 is missing because we use the if I is equals to 3, go to next. What this does is, it doesn't go to this line, it actually jumps from next back to the condition. Okay, so anything that you write after next will not be executed. That's why now we have print afterwards, after we have done the increment. So here what we're trying to do is, we are printing the statement at the end, and then we are using the skip or the next statement before the printing statement. So if the value by I is met with respect to 3, just skip that value, don't print it. Okay, so this next allows us to do that. Hence we have that value skipped here. Make sense? A little bit, right? So this is wherever we need to do that, basically we go with that things. So if else combined with the while loop. To demonstrate a practical example, let's say we play a game of Yahtzee. Print Yahtzee if the dice number is 6. Okay, so if dice value is 6, so in this case we are not using a random value, just take a value 1. So while dice value is less than 6, because again it has to be less than equal to 6, if dice is less than 6, print no Yahtzee, else print Yahtzee, dice plus plus 1. So whenever the value of variable reaches to 6, it prints Yahtzee things. Okay, so if you use it, it will just simply do that. So if the loop passes the value ranging from 1 to 5, it prints no Yahtzees. Whenever it passes to the value of 6, it prints as Yahtzee. Same as that. I think stupid game, but it's there as an example for W3 schools. Make sense? Perfect. Let's talk more about for loops. Okay, so now talk about for loops. Well, okay, so loops also work with similar to while loop, that they execute certain block of code again and again and again and again. However, this is difference in syntax and how we write the condition statement. For loop is used for iterating over sequence. That's the primary purpose of a for loop in our programming language. What for loops does is that it allows us to control the iteration over a particular sequence of characters, over a list, over a data, over certain big, for example, loops for lists or sets or dictionaries, something that has a sequence of characters inside it. Okay. So what it does is that we use the for loop, x in 1 colon 10 print x. Now what's happening here is, let's debug this a little bit. So the for loop again is a loop that will reiterate itself or continuously cycle through this print statement until this condition is satisfied. Okay, so this is the key part for the for loop. So you see, it's not simple as in the while loop. It has a little bit typical syntax. Let's break it down. First, the condition 1 colon 10. What this is what we call a sequence. This basically is known as a range. So what we're telling it that start from 1 and up till 10. So this colon here is indicating a range of characters, or in this case range of numbers from 1 to 10. Okay, then we are using the in keyword here. So technically in more other programming languages, it's also known as for in loop. Then we have the x variable here. So there are three main things. We specify a range, we use an in keyword, and then we use a variable here. What's happening here is that the for loop or for in loop specifically is quite powerful. It does multiple tasks using this simple single line of code. What it is doing is, first is specifying the range using 1 colon 10. Second, it is saying that read the first element from this range in this range, because using this in keyword, it is reading this in keyword. And then in this range, read the first character, assign it to the variable x. Okay, so see, these three things are happening. Range is being specified, reading the first character using the in keyword, and then assigning it that to the x variable. And then we print that x variable, hence it prints 1. Then again go back to the loop. Now because we have already printed 1, the in keyword automatically will traverse to the next item in your list or in your sequence. So now it will take 2 character, assign it to the variable x, and the value is printed. Then again go back to the loop, take character 3, assign it to the x, print the variable x. Similarly, up till 10, assign it to the variable x, overriding its previous value. So whatever previous value was, override it and then print it. So it will print us between 1 to 10 values. So if you execute the code, you would see that we'll have 1 to 10, even though there's just 3 lines of code. How it's working? This 1 colon 10 is actually specifying a range of characters from 1 to 10, range of numbers, in fact, sorry. So what we do is we specify the range, then using this in keyword, we traverse through this entire range. So it reads the first number, assign it to the x, reads the second number, assign it to the x, reads the third number, assign it to the x, overriding the previous value, the value of x is printed until we reach the end of the sequence. And then that end is also marked by the in keyword itself. So the in for automatically knows, hey, we have reached the end, hence the condition becomes false, just break the loop now. So after 10, because there is no more range, the loop will automatically stop. So it prints from 1 to 10, a complete sequence. Now this can be your array, this can be your list, this can be your enumerations, your data, your Excel file, whatever data, your range of sequence you are reading, basically you can read that using this simple for in loop. Okay, so we'll talk more about lists and vectors in next sessions, in other sessions where we talk about these data structures here. So do keep tune in. Okay, then let's talk about the break statement. Again, yes, similar to the while loop, the for loop also has a break statement. So if you are looping through a certain list, so for example, in this case, we have created a list of items using R programming. Here, the list is apple, banana, cherry, 3 different items, comma separated. Okay, so comma separated, apple item, banana item, cherry item assigned in a list, and they have been given a name called fruits. So now we want to traverse through this list of items, okay, or we want to loop through this list of items, print each item individually. We can do that again, same for x in fruits. So now instead of giving a range 1 to 10, we are passing it a list that contains actually multiple items inside it. So now we're saying, hey, go inside this fruits list, read the first item, assign it to the x. Then next time, again, if you print it, then next time go back inside the lists, fruits lists, fetch the second item, assign it x, overriding the previous value, print it. Then go back into the list again, print the third item, assign it to the x, overriding the previous value, print the item of x. And then it works. But because we have used break here, so we're saying as soon as you find cherry, just break, do not print it. So this will again stop the execution flow and the for loop exits. So in other case, if you have found the word cherry, just break it. So we can have some other statements, hey, character found, and then just print it out. Make sense? Similarly, the next is also there. It skips a beat. So if you want to print a statement, see, banana is not printed because we are saying, hey, loop through these fruits. If you find a banana, just skip it. I don't want to see the banana as an output. So if you want to skip certain words out from your selection or from your sequence, this is the one way of doing it. That print all items except banana, or there can be many other items as well, depending on what you want to do. So the next will actually skip an item, but it will continue the loop. The break will stop the execution flow and end the loop completely. Okay. Same thing goes with the Yahtzee game. I don't want to say this, just go through it. Make sense? Let's go for nested loops. Now, nested loops basically means loop inside a loop, and they become sometimes very tricky and sometimes very, very useful. The way they work is that we define a list one or any other sequence for that matter. We have another list called fruits. So we have adjective and the fruits list. Then we say for X in adjectives. So first read through each item of this. So read the first item, which will be read, assign it to the variable X. Then inside the body, we have a for loop. Okay, so we say for Y in fruits. So now read the first item of Y in terms of fruits, first item of fruits, assign it to the variable Y. Then paste means paste the value of X and paste the value of Y inside the print statement. The output will be quite interesting. Now you see, we have a bunch of data. What's happening now? Let's debug that. The way the nested loop works, that for every single iteration of an outer loop, the inner loop completes its entire cycle. So for example, if there are 3 items, for every single item for the outer loop, the inner loop will execute 3 times based on the number of items inside its list. Then again, for second item, again it's going to execute 3 times. Then for again third item, tasty, the inner loop will again execute 3 times for its items. Hence you would see red apple, red banana, red cherry. So actually red is being fetched only 1 time in the X variable, but the fruits Y is actually being executed 3 times. So we have red, we have banana, and we have cherry. Similarly, if you go for big, now again for the next item, again the loops executes 3 times. So big apple, big banana, big cherry. Again then tasty, so we take 1 item, outer loop, inner loop executes 3 times. So outer loop actually executes only 3 times based on items that we have here. But inner loop has executed 9 times. Based on that, for every single iteration of outer loop, the inner loop executes 3 times. Then again single iteration, again inner loop executes 3 times. Again single iteration, again inner loop executes 3 times. So the outer loop only executes 3 times, inner loop executes every single time for the single item. So it executes 3 times. That's what the nested loop basically allows us to do. Okay. So sometimes a little tricky to understand, but the basic idea is that we have a loop inside a loop. Every loop will complete its cycle and then relinquish the output or relinquish the control. So when this loop executes for the first time, this loop will come into control and it will complete its entire cycle before the control goes back to the outer loop. And when for the outer loop second item, again the loop will execute, because do remember that looping means the same statement gets executed again and again. So the statement in this case, because they are looped, they will keep on iterating until the cycle is complete. Then again control goes back to the outer loop. This executes third time, and coming back here, this will again execute multiple times. So that's how the loops tend to work. Make sense? Perfect. Finally, let's round this session off with understanding how the functions tend to work inside the R programming language. Well, typically a function is a block of code which only runs when it is called. It's a block of code that performs a specific task. We use function for wherever we need certain block of code to be executed again and again and again. Okay. So for example, if you are doing addition, you know that if you're building a calculator, the addition is going to be done again and again. So we use a function and we put the addition function there. So that every time you hit the plus, it reads the two values and this gives us the answer back. So you don't have to write the code again and again. We have a function that does the task for us. Same goes for every other mathematical operation. So a function typically is a block of code which only runs when it is called, and you can call it as many number of times as you want. You can pass data to it, known as parameters, into the functions, which they can use and do calculations or operations on them. Functions can return a value as a result, return a value in terms of answer. So when they perform a function, they can give us a reply or give us an answer. Okay, so how do these all operations work? Well, first step is creating a function. To create a function, we use the function keyword inside our programming language. So we say my function. Again, this is my function name. So I give a function name. Any name is legitimate as long as there's no space between the name. Same variable rules actually apply here. So make sure it's all small case or camel case, and then it has underscore but no special characters, or doesn't belong with doesn't start with a number as well. Okay, so the number can be later on in any word, but should not be the first character, should not have a space. So we use a function name, which is my custom function name. We use the arrow function, similar to assigning a value. We assign it a function. So this is basically, and you can assume that this is a variable, but instead of assigning it a value, we are assigning it a function. So now the function is basically being assigned to this variable. Hence, this becomes a function now. So it also, because this is a function, every function has a block of code, an ending block of code, curly brackets, and then we write a bunch of lines here that can perform a specific task. Okay, so this is how we execute the function. Similarly, once you declare a function, then you need to call the function as well. To call the function, use the name parameters. So for example, we use my function, arrow function, and then function itself, the keyword, block start, block close, we have a print statement. That's a typical sentence of declaring a function. To call a function, we use the my function, and then this time only use the parentheses. No longer needed, all of these operations are omitted out. So we use simply my function, parentheses. Now notice we use print. It has the similar syntax because print also is a function and it performs a specific task of printing whatever we write inside here onto the console. Okay, so this is what we're doing. So now we are declaring our own custom functions. So this is called function declaration. This is called function calling. We can call this function as many number of times as we want. Every time we call, it will go and execute the block of code. But to make more sense, we use arguments. Arguments are basically information that can be passed to the function. Okay, so we specify arguments here inside the parentheses. You can specify one argument or multiple arguments for that matter. As many arguments you specify will actually be passed to this. Hence, you need to receive those arguments here as well. This is called parameter now. So this is argument passing. This is called parameter receiving an argument, interchangeably actually used. So what now we're doing is we're saying, hey, I have a variable called fname. So when you pass it an argument, this Peter will be assigned to this variable. Because I'm calling my function with an argument called Peter, this Peter will be assigned to this parameter now, this variable fname. And then I can use paste function to use the fname and then provided some other valuable information here. So if you run the code, you will find that it prints Peter Griffin or Lewis Griffin or Stevie Griffin. So you are calling your function multiple times, but every time you call, you are giving it a different argument. Okay, so if this can be your addition function as well. So you can have 5 plus 5, 5 plus 7, or whatever operations you're doing. So the add function will have different number of arguments. Every time you just pass the arguments, it will take the arguments value, do the operation, and then return an answer to you. Okay, so this is what function is. So now two terminologies, parameters or arguments. As I said, in my understanding, we just use it interchangeably. But typically we say when we pass a value, when we call a function, this becomes an argument. And here, this is basically known as a parameter. That's the major key difference between it. Okay, so number of arguments, obviously, as I said, you can pass multiple arguments as well. So here we are passing multiple arguments. We are saying fname, comma, lname, means that we're telling it, hey, this function has 2 arguments. So because we have specified 2 arguments here, when we call the function, I have to ensure that I do pass it 2 arguments. In this case, because I declared only one parameter here, hence only one argument is given. Okay, and in this case, we have 2 parameters. Hence, when I call the function, I need to ensure that I pass 2 arguments. So when I say Peter will be assigned to the first fname, the second argument will be assigned to the second parameter automatically. And then we can use fname, lname, and then the paste function to paste the values of these two parameters. Okay, so if you don't pass it two arguments, this will generate an error. So for example, if my function takes two parameters, means this is the function declaration. We have declared that my function has to have two arguments. But when you call the function, you only give it one argument. The second one is missing. Hence, the R programming will get confused and it will only print error here. Because hey, he say, I need two arguments, you're just giving me one. So that just creates a problem. Similarly, in arguments, there's something called default parameter value as well. Okay. What this will basically mean that in case where you are not sure whether you will be passing two arguments or one argument, you can set these arguments with the default value just to ensure there is no errors and ensure that the error debugging can be done easily. Okay. So in case the arguments are missing, there's still the default value. So it's a fail-safe mechanism. To do that, we use country is equals to Norway. Notice we are using equals here, not the arrow functions for some strange reason. Technically should be an arrow reasons because all this time we have been using arrow functions. Anyway, some strange thing happens every time. What we're doing now is we're telling it, hey, listen, I have a country variable equals a default value of Norway. Then I paste the value of country here. So if I call my function Sweden, it will use my function Sweden. If I say my function India, I'm from India. If I don't provide an argument, if you don't use this default value, this will generate an error because it says, hey, I need a parameter. You have not specified the parameter. But because I have used the default parameter value, even though I have not specified any argument here, this will go and print the default value called Norway. And that's what the fail-safe mechanism basically means and allows us to have, that you can use a default parameter with a default value. In case if the value is not passed, still it will run and use the default value in that case. Finally, the key thing within the functions is known as return values. To let a function return the result, we use the return function itself. What this basically means is that I have a function, it performs a specific task. After completing its task, this function will return a reply. This function will give us an answer. That's the key point here, that whenever in previous examples here, there's no return function. So when you execute, there's nothing printed here. There's no return answer coming from here. However, in this case, we use a return, bracket start, bracket close. Inside the return function, we say, hey, 5 multiplied by x. So whatever the value of x is given as an argument or passed through this parameter will be used and multiplied with this. But this will not print the output. In fact, this will return an answer for me. So it says print my function 3. So now we have used my function inside the print statement. Why we have done that? Because again, first thing, my function, we pass it an argument called 3. Argument will be assigned to this parameter. It does the calculation, but then it returns a reply. Because this is returning a reply, I need to receive that reply. Hence, I've used this my function inside the print method. So whatever reply comes from my function gets printed on the console. Whatever reply comes from my function gets printed on the console. Whatever reply comes from my function gets printed on the console. So the output will be 15, 25, and 45 respectively. Understand? So the return function allows us to always ensure that when this function executes, it returns a reply back to this calling function. So whenever we call the function, it will receive and it will be getting a reply back. So because it's receiving an answer, we have to have a mechanism to receive that reply as well. Okay, so we say we put this in print method. Okay, or this can be another variable for that matter as well. So when whatever answer is returned from here can be assigned to another variable for that matter. Make sense? Perfect. Okay, so I think that concludes the basics of R programming. We're not dwelling into too much detail now. In next sessions, we will try to go as much detail as you can. So, but do let me know in comments how far you have reached and how much are you interested in going into these further topics, so I can actually make the videos. So if nobody's interested, I don't want to delve into something of that sort. But yes, so if you have completed up till this point, followed all the 5 sessions, excellent. Thank you very much for watching that long. And do leave your comments. Let me know what you're thinking. And then if you're interested in the next chapters, please let me know in comments so I can actually have a motivation to create these videos much quickly. other than, if not, I will just keep on creating them on my own pace, so it might be a little delayed. Okay, so thank you for watching. This is Dr. Zishan signing off.